Okay, so today we talk about friction. Okay, so again, we are choosing these very special, okay, how many engineering forces do we have? No, 5. We are choosing a couple of them to actually extend, like the concept on before we start actually combining all of them. Which one of the 5 did we already talk extensively about? Gravity, and today we talk about friction. Normal, tension, and applied, you really can talk about them because they are reactive forces. Friction and gravity are very interesting in their own way. Okay, so let's talk about friction. Friction is the force that can either do one of two things. Okay, everyone, is this moving right now? No, it's not. Okay. Do you think I'm pushing? You can see the veins pop. How come it's not moving? Say again? I'm not pushing hard enough. So in relation to what am I not pushing hard enough? That's my point. So friction could what? So you could still apply a force. By the way, if this was on ice, would it be as hard as this to move? No. So that means what? Friction does play a role, and friction could what? Keep things what? Stationary. Okay. How about when I apply hard enough to move? What does friction now try to do? So friction is either what gonna stop you from moving, or what? Once you start moving, what? Slow you down. Perfect. And that's a very important distinction. Is the force that either prevents a stationary object from even beginning to move when a force is applied on it. As long as there's no force applied, there's no friction. It's there, but not experienced yet. Okay? So that's one way of thinking about friction. If nothing is moving yet. What's up? Yeah, so friction is a part of what? Is a part of, sorry, friction is an example of what? Of a reactive force. You're right. Gravity is not reactive. Gravity depends on a source, which means what? It's an active force, not a passive force. Almost, yes. Okay, besides electricity and magnetism and all that, almost everything is what? Is a reactive force. You're right. Yes. Okay? No, that's what makes them what? Fundamental. They have to exist even without anything happening in the situation. Good. Good idea. Or if you start to move, it's what? It resists or opposes the motion of an already moving object and tries to slow it down and even bring it to a stop if it has enough distance, if it's strong enough, and so on. Okay? Therefore, we have to define two types of friction. Two types of friction. What do you call what's the scientific word for something that doesn't move? Anyone knows? Station, but okay, so it kind of like sounds like stationary. Static. Thank you. Static friction is when you are not moving. Sorry, not you. When the object is not moving yet. Okay, who would like to tell me what's the opposite of static? Nice. Kinetic. So kinetic friction. Sorry, kinetic friction. Motion already exists. Okay. So that means we're gonna have to do what? Two different kinds of slides. One for static, one for kinetic. All right. So let's start with the first one. Static friction. What is static friction? It is the force of friction that you go against when you try to what? Move a object that is not moving yet. You put more in, and as long as it's not moving, what's opposing you is classified officially as static friction. Oh, that that everyone, that brings up a very important point. From now on, you cannot just call it what? You cannot just also call it what? Friction. You have got to what? Either what? From now on until the end of the course, you cannot just use the word what? Friction. You have either to tell me if it's static or if it's kinetic, depending on what's happening at the situation or not happening at the situation. Nice. Okay. So everyone, what is the symbol, everyone, for the maximum amount of static friction that is basically making sure that the object doesn't move? Okay. Instead of FSF for static friction, no, it's just what? Make it easy. FS. Yep. Uppercase S or lowercase s doesn't matter. As long as your capital F is there, everything is okay. Why is there no arrow needed? By the way, technically, it's still a what? It's still a force, it's still a vector. Why again is there no arrow needed? Yes. Thank you. Or so because you're always gonna give me a direction, like gravity, you're always gonna tell me which way it goes. I don't need an arrow. Okay? All right. So everyone, this is gonna be a big part of next week's lab. Whenever you deal with friction, by the way, this is also a very important thing in first year physics as well. Whenever you deal with any kind of friction, there is a specific number called a what? Who can read that word? Coefficient. Coefficient coefficient in physics means a specific number relates to a situation. I'll give you an example. How many people here did grade 10 science? Grade 10 science. No, how many people did grade 10 science? You have to be in this course. Yes, I know. What was the physics part they taught you? Remember, I think in chemistry, what was chemistry grade 10? It was the orbitals and the Bohr-Rutherford diagram. The biology, I think it was the cardiovascular system, or whatever the biology teacher. What was it in physics? What was the physics concept you studied in grade 10 science? Say again? Light. Light. Or, and what things did you study about light? Sadly, we don't do light in grade 11. We do light in grade 12. In grade 11, we do waves and sound. In light, in grade 12, we do waves and light. What are two properties of light that are so important, especially in designing lenses? Reflection and refraction. How many people remember something called index of refraction? Uh, it's the thing that tells you how light bends when it goes into a what? A glass-like medium, like something could pass light. That index of refraction, some people call it the what? The coefficient of refraction. That's my point. If some number is associated to a certain material, it's usually called a what? Coefficient, okay? So there's a very specific number called a coefficient that's associated with static friction. The name is very easy. Coefficient of static friction. Okay? Again, they ran out of names. Even geniuses do that. The interesting thing that probably none of you have seen so far is the is the physical symbol they chose for it. Okay, everyone? They actually did not go with an English character. Not Latin, Greek. So how many people know Greek characters? Give me a bunch of Greek characters. Actually, you can say it like ABC: alpha, beta, gamma, delta, epsilon, like the E, and so omega, sigma. Sorry, uh, pi. Pi is what? Theta, right? Which one did they choose for coefficient of static friction? Ladies and gentlemen, it might look hard to write. I'll show you a very easy way. It's not really. Nope, not sigma. Okay, it's like a U. It's like a U. Look, I'm gonna zoom in. It's like a mu. Mu. This is the what? This is the Greek M. M. M is mu. N is what? Nu. I'm not kidding. Mu followed by nu. Okay? The symbol from you, don't go crazy with it. Just do this. Look. Yes. Sorry, it is here. It's like this. Look. That's it. So it's like a U with a what? With a dash or a tail at the beginning. Just make sure it doesn't look like a what? Some people write sloppy and it looks like this. Look. Again, I will understand from your handwriting on tests and so on. But please do not write it like this. Because that to me looks like an M. Make sure you go up and then you just write a U. And it has a subscript. What? Okay. We're good so far? So it's called mus. Mu. But no, because by the time they actually chose symbols for this, maybe most of the English characters were taken for something else. So they went with what? They went with the Greek. By the way, they usually go with English. If they ran out of the English, they go with what? No, Greek. And then a few times, actually, I've seen what? A couple of them, they actually had the Hebrew characters. Okay? But most of them are what? English and then Greek. Don't ask me why. I was born into this as much as you were. I was not consulted. Yep, 100%. Any variation of this, everyone, any variation of this is acceptable. Just do not make it what? Like this. For example, just make sure it looks neat. Okay, let's talk about that mu s for a little bit. Okay. Here is the defining formula that we will use next week to what? To calculate those three things. The coefficient of static friction is equal to what? Is equal to the maximum what? So the maximum amount of force it takes to get something to move divided by what other specific force we dealt with? No, divided by what force? Divided by the normal force. Divided by how much the surface is pushing. By the way, can you always say that the normal force is always pushing up? Is it always? Yes. By the way, can you say that most of the time it happens to be pushing up? Yeah, most of the time. But most of the time does not mean what? Does not mean always. Thank you. Okay? So the coefficient of static friction is equal to maximum static friction force over normal force. What's the symbol for this one? Fs. Now, can you rearrange it to look like the other one? By the way, what's the rearrangement process that I followed from here to there? What did I just do? How do you rearrange anything with a fraction? Thank you. I literally just what? Crisscrossed. So I just put a 1 here. And I cross. And I get Fs equal mu as well. By the way, how many variables are there? How many variables are in either equation? 3. What does that mean? As long as I give you how many? No. 2. I have to ask you for the what? But I need to give you how many? I need to give you 2. There's no way I can just give you one of them and ask you for one of the other 2 because that doesn't make sense. Okay? You can never solve for an equation in 2 unknowns. Okay. Let's talk about the what? Yes, they are equivalent. Okay, everyone. Does it say 3 or 2? Okay, everyone. Question for you. Pencils down. What's the unit of? If I ask you right now, what sine? Go ahead. What sine of what sine of 30 degrees? I don't know if anyone knows remembers their special angles from grade 11 functions. What sine of 30 degrees? It's what? It's 1/2 or 0.5. Here's my question to you. 0.5 what? What's the unit? No, I said 30 degrees. You cannot start with degrees. Say it. Sine, cosine, tangent. Do not have what? Why? How come something doesn't have units? Come on, let's define it. I know it, but so let's revisit it. What's the definition of any sine of any angle, especially in a triangle? What is it? SOHCAHTOA. What does that mean? Opposite over, huh? So hypotenuse. Okay. So if this is your angle, come on. If this is your angle, where's the opposite? Where's the hypotenuse? Where's the adjacent? All of these things are what? Like all of these things are what? Are sides. How do you measure sides? In any what unit you want? In any, does it have to be meters? In any what? Length or distance units you have. Let's say you measure it in what? When you divide inches by inches, what happens? What happens to the inches? There you go. So for example, to Muhammad's point, Muhammad, you said this angle is how much? 30. What did you tell me the sine of 30 in any triangle is? 1/2. What does that mean? The opposite divided the hypotenuse has to give me what ratio? 1 to 2 or 1/2, which means if this one is 13 inches, this one has to be how long? 26 inches. So now what do? You say what? You say 13 inches, and then you what? 26. What happens to those two? Is it making sense now? So, by the way, does this happen a lot in physics and math? No, almost everything else has a what? Things have units, except in what? Very special cases where things are what? Where things are what? Dividing each other, and they have the exact same what? Same unit, so it cancels out. So let's actually think about this. How do you measure anything that's a force? Any force, how do you measure it? With what unit? Newtons. How do you measure this force? So what can you tell me today about the coefficient of static friction? Does it have a unit or no? It is a unitless number, or as they like to call it in fancy math or physics, dimensionless. Dimensions and units are usually thought to be the same. But what do you call it? You call it what? Unitless number. Perfect. So that's the first what? That's the first feature. Go ahead. It has no units because newtons cancel out. Okay, pi. Give me an equation for pi. What do you call capital C in geometry? Circumference of what shape? Who remembers the equation of a circumference? How say again? 2 pi r, or 2 times r is what? A diameter. So some people like to call it what? Do you see what I mean? Either you do it what? Twice the radius, or what? A single diameter. How do you, let's say, how do you rearrange this one to solve for pi? Pi equals what? Capital C over, what C stands for? Circumference. Circumference really is a type of what? Line, length. So how do you measure this one? In what, let's say? How do you measure diameter? What happens? There you go. Pi is the diameter. Because pi is the what? Is the perfect ratio between the what? The circumference of any perfect circle and the diameter that cuts it halfway through. Yes. Yes. Okay. What's the other, everyone? What's the other, what do you call it? What's the other property? It's an interesting property. It's a decimal. It's always a decimal. Less than 1. What does that mean? If you have a fraction less than 1, which one is bigger? The top or the bottom? If you have a fraction less than 1, which one is bigger? The bottom, yes. So that means what? By definition, the mu(s) is always going to lead to what? Static friction force is what? Question for you. Can I say less than, or can I say or equal here? What does the statement say? It has to be what? Less than 1. I didn't say what? Less than or equal to 1. If it was, I have to put what? I have to put what? Come on. I have to put what? The equality thing. Like I have to make it this way. Did I do that? No, I didn't. Done. That's it. By the way, another question for you. I didn't bother saying it's a property, but it is. Could the mu(s) ever be negative? Negative friction coefficient. By that definition, could it ever be negative? No. Why not? Because what are you dividing by each other? You're dividing two what? Two forces. Forces, by definition, even though they might point against each other, but by definition, a force is a what? Negative or positive thing? A force is a positive measure of how much you're trying to what? To affect a state, a system. Even if something is pushing against you, okay, remember when we assigned positive and negative direction? Does something pointing in the negative direction make it negative? Like when you got negative velocity, is there anything negative about that motion? No, you just said that it's going which way? The other way, backward. But there's nothing negative about my speed or my pace. Same thing. Can you ever get a negative normal amount of force? Can you ever get a negative amount of friction? Which means by default, the mu(s) also has to be what? Positive or negative? So everyone, in your notes, add another property. Actually, so cross this 2 and make it what? 3. And the reason I'm saying cross it and make it in your notes, because if you're ever doing the math and your number came out to be what? Negative, even though friction points which way? Against, which usually is given what sign directionality? But that doesn't mean that the number itself is negative. So everyone go ahead and cross this and say 3. Come on, 3. And add a 3. What are we going to say in the third process? Sorry, property. Cannot be negative. Must be, oops, my bad. Must be positive. Remember how I write positive? Plus VE. How do you write negative? Minus VE. All right. Okay. So that's all we need to know about what? The coefficient of static friction. The coefficient of static friction. Okay. Next slide. Okay. Okay, everyone. Question for you. Listen up. Don't worry. Just got to push a little bit. Am I pushing? Is it moving? Do you think I'm increasing my push? Is it moving? So that means what? I start obviously with what force? And then if you had a force meter connected to my hand, what's happening to the force amount I'm putting in? Going up, going up, going up until I hit what? A perfect value that did what to the friction? Perfectly what? Can't no, no, to the friction. It just what? Canceled it and went what? A little bit what? Over it, which means what? I have now more, sorry, I'm applying now more force than what? Than the friction on these what? On these legs. Make sense? What does FS stand for or give you? It does. Here's my point. It doesn't give you all the forces before. It tells you exactly what? The, the minimum amount you have to what? Put in to get something to what? Do you see what I mean? So that equation is very convenient. It doesn't tell you all the what? Look, it doesn't tell you all the what? All the meaningless ones you went through. It tells you immediately what's the what? What's the highest one that you have to go against? Or what's the minimum one that you have to what? That you have to put in. Is it making sense? So remember, Fs is not just any friction force. It's the what? It's the maximum resisting or the minimum applied that is needed to get something to what? To get something to what? To move. Exactly. Make a note of this, okay? Let me give you an example. Think about it this way. Everyone, don't copy this. This is already done for you. Let's go back to the pushing a textbook to the right along a surface of a table. Let's say you start applying a very small force such that you confidently know would not do anything. As time passes, you are continuously increasing. Okay, snapshot number 1. What do you conclude? You're putting 2 newtons in, but there is no motion. What do you conclude about how much the surface is given back? But no, at least what? Thank you. It's at least 2. Okay, it's like you're testing the system. Okay, 2 newtons. You increase it up to 4, and yet what? What do you know? The friction is as strong at least as what? You keep going, and then you notice that at 6.0001, it just what? What do you conclude? The maximum amount the friction was given against you was probably how much? 6. And that 6 is the one predicted by what? Predicted by the what? By the formula. Do you see what I mean? The Fs is not this equation. Everyone, look, eyes on me. This equation, if you work it, it's not gonna give you what? Or what? It's gonna give you what? It's gonna give you 6, which basically that's my point. You have to what? You have to just go. By the way, again, if you have 2 forces perfectly identical pushing this way, would anything move? What does that mean? Yes, you have to be slightly what? Slightly higher to get what? To get some motion going. That's it. Therefore, the mu-s equation only gives you, which honestly is good, because who cares about all the ones you have to what? You have to go through. You just tell me how much force do I need to move that fridge, and I'll try to give you that force. That's it. The maximum value of opposing, preventing friction, and just not just any value of lesser friction. Okay? All right. Kinetic. What does static friction do? It prevents a what? A non-moving object from what? From starting to move. How about kinetic friction? That so you've already what? Were able to what? To move it. What does kinetic friction now do to you? It's trying to what? Suck energy out by stealing heat. By the way, when you rub your hands, what do you feel? Hot. Because whenever friction, by the way, friction losses always result in what? The most energy that actually comes out of friction is what? Is heat or thermal energy. Question for you. What makes this stop? Friction. If you had a temperature sensor sensing the what? The temperature of this rail, it would register a very slight what? Increase in what? In temperature. Because of what? Because of friction. Okay? All right. Go ahead. It's the force that what? That you go against when you try to keep moving an object already in motion. What do you think the symbol is? Come on. One of them was Fs. What should this be one? What should this one be? Fk. No, again, no need for 2 subscripts. Just one. Fk. Everyone? Fk. Uppercase K, lowercase k, whatever you want. Just make it a K. What do you think is associated with this one? Another what? So another what? What did you call the Greek letter? Not symbol. No, the name. The name starts with C. Coefficient. Thank you. Another yet coefficient. And the name is also easily the coefficient of kinetic friction. What's the symbol this time? No, no, no. Still what? Still mu, but with what subscript? Do you see the similarity? Fs is associated with mu s. Fk is associated with what? Mu. No. Fs is with mu s. Fk is with what? There you go. You got it. There's only 26 choices. Actually, if you think about it, there's only 52 choices. 26 capital, 26 small. There's much more than that in science. Fair enough. Oh my God. I think we used it. We used mu. Mu. Yeah. Wow. I don't really remember الاحتكاك في السعودية. Wow. Been 26 years. Okay. All right. What was the everyone? What was listen up? What was the equation from US? What divided by what? Come on. Fs over Fn. What do you think it should be for the mu k? Only one thing changes. Instead of Fs, you have what? What stays still? Normal force as well. Again with the rearrangement as well. You crisscross. Okay? Can you tell me again what should be the three properties of this one as well? What's number one? Again, are you dividing two forces? So what's the first property? No what? No units. It's a unitless coefficient quantity. Yep. What was the second property? Again. Sorry, what was the second one? Has to be a decimal between what? 0 and 1. By the way, could it ever, question for you everyone, either one of them, mu s or mu k, could it ever be 0? What does it mean when you have a 0 friction coefficient? Even look at this. Even look at this equation. What does it mean when this guy is 0? When you have a fraction equal to 0, which part of the fraction is always permitted and allowed to be 0? The bottom or the top? Can the bottom ever be 0? Which means if you want to kill a fraction, what do you put the top? What does that tell you? 0 what? 0 friction. Which means technically, what kind of a surface do you have? The most perfectly smoothed out surface ever. Can that ever happen? No. By the way, no, not even ice. Not even. Okay, question for you. If you slide something on ice, no matter how smooth the ice is, would it go forever? It has to what? But it takes what? A long distance, long time, which means technically it's very close to 0, but it's not what? It's not 0. So the three things are no units, less than 1. Also what? What was the third one? Must be positive. How can you get negative? There's nothing negative about friction force as far as magnitude is concerned, and there's nothing negative about how much a surface pushes up, which is normal force. Okay, so again, change this one to 3 and make it 1, 2, and 3 is the same thing. Must be positive. You cannot get it negative. I don't care what the math tells you. If it gives you negative, your math is wrong. Okay? All right. So let's talk about both of them together. Say yes. Let me just finish one more slide. It's exciting more because it's comparing both of them. I believe so. Yeah. Okay, everyone. Let's go next slide. Okay, pencils down, everyone. Pencils down. Okay. Here's a table. Everyone, do not look at your notes. Look at this table. Oh, my bad. Which one is it? Oh, yeah. Okay. What do you have a table here? Everyone, just look up here. This table has how many columns? 3. What do you have here? What do you have? But look at how the materials are laid out. Are they repeating a lot? They do. But what's happening to the repetition sometimes? either repeated the same way or with different combinations. I mean, look, rubber on dry concrete, rubber on, or steel on, steel dry, steel on steel, greasy, and so on. Okay, what's the second column? It's the values of what? What's the second column? Third column, I mean. Does anyone notice anything when I look at these ones? What do you notice, everyone? Raise your hand if you notice something. Raise your hand if you notice something about the numbers. Okay, Hamad sees something. Hamad, what do you see? Every time mu s is what compared to mu k? 0.78 is bigger than this one. This range is what? Say again, which one? Sorry, what is it? What does that tell you? It's either bigger than it or at least what? At least within experimental error, the what? Equal. But look at all of them. 1%, 0.3%, 0.04, 0.04, 14%, 10%, 22%, 18%. What do you now conclude about any mu s versus mu k? When you do the math, and you're going to do, by the way, we're going to do a lot of friction problems where you have to evaluate both mu s and mu k. What logical, even if your numbers are wrong, at least what you hope. What do you hope that your numbers are? You hope that whatever you get from mu s is slightly what? Bigger than what? Than mu k. Perfect. At least. Yes. So we observe that the coefficient of static friction is larger. Let's say larger. Okay, let's say within experimental error, it's always gonna what? It's always gonna exceed the coefficient of kinetic friction. In mathematical terms, you can just say what? Done. Mu s is bigger than mu k. Okay. Once you write this, everyone pencils down. I'll look at the screen here. Okay. What's the equation for mu s, everyone? Oh, sorry. What's the equation for mu s? Come on. Equation for mu s. Mu s is equal to what? Fs over Fn. What's the equation for mu k? Come on. Sorry. Fk over Fn. Okay. What did you think? What did I just say? Which one is bigger? This one is bigger than if. Which one of those is the same? Which one of those is the same? So, as far as you're concerned, are you fairly dividing both of them by the same thing? Which means what? If this one is bigger than this one, if a value is bigger than another value, and you keep the bottom of the fraction the same, what can you tell about this one compared to this one? None. So what does that tell you about moving an object versus keeping it moving? Which one is harder, to get it to move or to get it to keep moving? Which one is higher, static or kinetic? So which one is always harder to do than the other? To keep it in motion or to even start it to move? To start an object to move is always harder and takes more force to what? To change the state of the system. Yep. I'll give you an example. Have you ever tried pushing like a heavy fridge? What happens first? What happens first? What happens first? You're pushing, you're pushing, you're pushing. And then what happens? Why? Because it took much more force to what? To, to, to start it to move. Once it started to move, did you need to keep all that force going in? You needed to what? You needed to what with your force? Increase it or decrease it? Because you don't need as much. But can you decrease it immediately? No, you can't. And that's why you what? That's why you what? You fall because you were still applying all of that force, and the fridge literally what? Escaped away from you, right? It accelerated so quickly, it escaped, and then you fall. So it always takes more force to what? Come on. It takes more force to what? To start moving than to keep. Start and keep. Start moving is harder than to keep moving. Okay? Oh, that was a good hit. Okay? All right. Let's do a quick demo. It's okay. Upload it. Don't worry. Let's do a quick demo. Determine the coefficient of what? Okay, hold on. Why is this question a bit tricky? Determine the coefficient of what? Friction. Come on. We said there's no such thing as just friction anymore. You have to be what? You have to be specific. It's either what or what. By the way, can you ever have a situation where an object is under both static and kinetic at the same time? Who says no? Why not? You're right. Why not? Thank you. Because it's either what? Not moving or in motion. If you're not moving yet, you're in which kingdom? The what? The static friction's force. If you start moving, then you're what? You're under kinetic friction. Nice. So how about the first one? It takes a horizontal force, so like straight this way, 62 newtons, to get a 22-kilogram box to just start moving. What is that? Is that kinetic kingdom or static kingdom? To just start moving. Thank you. All right. So, by the way, do you think you really need an FBD to solve this? No, you don't, because you have an equation. But let's sketch an FBD quickly. All right. What object is mentioned here? A box, okay? And okay, part A. Come on. Box, and it's being what? Which means what force definitely exists? A normal exists, but also what? Slide. Okay. A. All right, come on. What's force number one all the time? Gravity. Question for you. Where do you have more friction? Moon or Earth? Why? What do you think friction depends on? How much they interlock together, right? On the moon, are you pushing as hard or less hard? Which means what? You don't have much you do not have as big contact as you have on the Earth, which means what? Less for sure. Yes. Okay. What reacts to Fg all the time? Well, not all the time, most of the time. Fn. Okay. Are you pushing on this? Yeah. How else are you going to get static friction to go against you? So let's say you're pushing this way. I'm choosing to push this way. Did they say which way? No, they didn't. Okay. And definitely, until it moves, what's going against you? Fk. What kind of friction? Fk or Fs? Static. So obviously, it can't go with you. It has to go against you. And you know me, I'm usually going to sketch it down. Okay. Okay, everyone. Listen up. This might lead to some debate, but it's healthy to have. Someone says, oh, you're going to start moving when your F applied is exactly equal to Fs. What do you think? It's not like a true-false statement. It will start moving when your F applied is exactly equal to Fs. How many people say no? Why not? Because how much higher? So, but here's my point with the decimals. You might use 5 decimals. Arabi might use what? 6. Tammy might use what? Am I going to mark 22 different answers? No. What do we assume? We assume, no. You know what? Here's the problem. We assume, let's make it equal. Let's make them equal. We just said that if it's equal, it doesn't what? But at least we know then what? If you know if it's equal, you just need to give me what? A little bit what? Higher. So what does the equal mean? Is that your maximum or your minimum offer? Do you see what I mean here? Calculate with the equal and then say what? That's the minimum it will take to what? To get it to what? Move. What I'm trying to do is I know some of you will think it will take slightly higher. How much higher? Bahat might say, oh, 62 newtons. So that means probably that Fs maximum is 59.99, right? Bahravi might say, no, it's 59.999999. Hamid might say, oh, I'm going to give you even 10 more 9. Is there any point to this? What do you just say? 62 here, and also what? 62 there, and that's where. Do you see what I mean? How many people here are going to take grade 12 functions? Okay, because if you're going to take calculus, you have to do that. Grade 12 functions, there's an idea of, has anyone heard of something called limits? Limits? Yeah, what's limit? Limits means what? You get as close. Okay, you know what? Forget grade 12 functions. Let's talk about grade 11. How many people know what asymptotes are? What's an asymptote? Whether vertical or horizontal. What does that mean? You get what? You get what? Closer and closer and closer to that trouble point, but you never what? Touch it. That's the exact same thing with what? With static friction. You keep what? You keep getting closer and closer to that what? Minimum value. And then you what? You exceed a little bit. So what's the point of you getting 3 zeros and you getting 4 zeros and you getting 5 zeros? Who cares? Just make it equal. Do you see what I mean? I'm basically making an exact value for all of us, and we call it a day. All right? So we're going to say what? Oh, by the way, what do you know about these for sure? They have to be what? Otherwise, it's going to what? Sink down or jump up. We know that it's not going to happen. So we don't care about the vertical. I care about the what? I care about the surface. I'm moving on. So everyone, we're going to call what? F applied must equal what? You say Fs. How much are they telling us you're applying? So instead of F applied, you put under it, you put 62. Do we have an equation for Fs? Come on. What is it? So okay, so Yasmin is telling me mu s is equal to Fs over Fn. That's fine. I need the part of the equation for the Fs. Over? Is it over? Multiply. Everyone remember? Remember this? Sorry. Fs equals mu s times Fn, right? Okay, yes. Not everything is going to be given to you. I might ask you to rearrange sometime. Okay, so let's go back real quick. Almost there. Okay. Oops. Okay, so what was this? It's been again? Mu s times what? No, F. Good. Everyone, look at the diagram. What did we say about F and Fg? They have to be what? And that's why you have to understand your FBD. There's a lot of information in your FBD. What do you say about those two forces? They're the same. So can you replace Fn symbol with Fg? Yes. If two things are equal, you can write one of them in terms of the what? In terms of the other. So let's keep going. 62 equals what? Mu s times what? Do you see what I'm doing? My diagram told me I could do that. My diagram told me it's not moving on the vertical, which means Fs must be perfectly balanced out, but what? By Fg. Do we have an equation for Fg? Yes, we do. Yes, we do. It's a short equation. It's a short equation. Fg equals what? Mg. What does M stand for? Mass. Do I have the mass? Heck yes, I do. All right. You see? Math. You break it down. So 62 equals what? Mu s times what? M times what? What's the question asking for? What's the question asking for? Come on, people. What's the question asking for? Determine the what? The coefficient. Which one of those three symbols is the coefficient symbol? The mu. I know it looks like a u. Mu s. Can someone tell me how I'm going to arrange this equation to solve for mu s? Okay, hold on. Mu s equals 62 canceled by what? Mg. Nice. So you divide by. Yes, yes. So mu s equals what? 62 divided by what? So 22 times what? What's G? What's just G? Just G. G on Earth is 9.8. Perfect. Come on, who would like to give me this number? multiply first and then divide. Or do the whole thing with division, but make sure you put the 22 times 9.8 in a bracket. Oh, the M is 22. They told me. It's given. See, the box is 22 kilograms heavy. The what? Yeah, go ahead. Oh, okay. Everyone, no, pencils down. Was this the only way to do this? Could I have multiplied those two here first? Yasmin, could I have done that? Do I know the math? Yeah. Do I know the G? Could I have just multiplied here and then divided? It's exactly what I'm doing. Oh, because FG is equal to MG. Remember from, oh, okay. That was the Friday. That was case number 3 in gravitation. If you, everyone, question for, okay, everyone, just to refresh for Yasmin. When can you only say that FG is equal to MG? When the object is what? When the object is on the what? The surface of a what? Of a huge planet. So whenever you want your force of gravity on you, all you have to tell me is how much mass you have, and I'm going to multiply it by 9.8, and I will know how much you weigh on Earth. Okay? By the way, the solutions are there, and the video is there. Just watch at some point. Everything will make sense. So, Muhammad, what's number? Oh, by the way, what's the specific situation here? So I need only 2 decimals after the 0. Point. Okay, 28 or 29? Yeah, 287. So it's 29. Remember, people, you don't just cut the number, you round it. Force again. Remember, I did not take marks off for rounding and stuff like that in kinematics. Starting from forces, everything fair game. Yes. All right. Okay, everyone. What are the 2 logical checks that this answer makes sense? It might be wrong numerically. I might have to redo my math. But at least what makes me breathe a sigh of relief, it's what? It's positive and it's less than 1. What's the unit here? Nice, no unit. What if someone says it's newtons? What do you tell them? How can you get newtons? The newtons here are going to be cancelled by the newtons here. Nice. Okay, everyone, let's look at part B. Ali, can you read part B for us? Interesting. Are we still moving the same box? Are we still moving it technically on the same kind of ground? So that means what? Did they change surface to surface? No, they didn't. But how? Go ahead. But how much force is it taking now to keep it moving? Same, more, or less? What did we say about Fk and Fs? Which one is harder? To start moving or to keep moving? Apparently, it's slightly easier to what? To keep it in motion than to what? Than to move it. Okay. Who can tell me how my diagram is going to change now? It's in motion, everyone. It's in motion. Would Fg change? Fg only depends on what? M and G. Did either of them change? No. Fg and Fn are going to stay the same, both in direction and in strength. Am I still applying a force? Yeah, I'm keeping it in motion. How can you keep something in motion without applying a force? Sorry, say again. I said I'm arguing the existence of applied force. How can you keep something moving without applying a force? If you don't apply your force, it's going to slow down eventually, right? But what are they saying? It's moving at what? Constant, which means something has to keep what? Pushing it, right? Good. What goes against me now as it's moving? Which again, I cannot accept the word friction now. I have to hear a word before. Kinetic friction. And what's the symbol? And now I have to add a what? A motion direction. Okay, question again. Are those 2 equal? Are those 2 equal? Okay, hold on. I just have to tell you that today. I'll tell you why it is true tomorrow. They are equal. You might ask, how can they be equal and it's still what? Moving. Thank you. It's neither slowing down nor what? Speeding up. Everyone, Newton's first law. If something keeps the same speed, that means the two forces on it are what? The same in magnitude, but what? Opposite in direction. Thank you. So everyone, for today, we're going to say what? We're going to do the exact same thing. But instead of Fs, I'm going to say what? Fk. Okay, everyone? Yeah, so F applied equals Fk. How much F applied am I giving in now? Come on. No. How much applied force am I pushing with? 58 newtons. What's Fk equation-wise? It's right there. Just like Fs. What's my second line? Mu K Fn. Okay, what's Fn again? Fn has to equal what? And Fg equals what? Am I ever going to take a mark off if you skip the Fg step and you just jump from here to here? No, because you showed me a diagram. Good. So 58. So I'm not going to take marks off if you jump from here to here. Because there's no way you got from Fn to Mg without saying to yourself, it's equal to that, and this one mathematically is that. Okay? Yes, but like, okay, I'm gonna give you an example of that in your practice assignment. I'm gonna give you the block, like the actual system diagram. All you have to show me is that the forces, some of them stay the same, but some of them what? Change. Yes. Okay. UKFN. What's FN? MG again. So I'm gonna skip now. And what do I do now? UK is equal to what? 58 divided by. Come on. Did the MG change? No, it didn't. So it's whatever product we had here. 200 and, which is equal to how much? Which one is bigger? The mu s.